Okay, so remember I put you may remember, you may not. I put a list of objectives on my website for the entire chapter. What are the things that are really important in chapter 1 that I want you to know? Okay, this is what we're going to cover today. Graph piecewise functions, that was a part of your video over the weekend. And then identify and graph 8 basic functions and use transformations to sketch graphs of functions. Now the 8 basic functions and the transformations, a little bit of that was a part of your summer packet, okay? And that's the part that I said, hey, we're going to talk about this again, so if you have questions, then we're going to cover it and we can see where you are. Okay, now a part of your summer packet was also identifying some functions, okay? We added one to that over the weekend, the stair-step function, the greatest integer function, okay? At the end of the period, I'm going to give you a chart that looks like this. It has 8 rows, okay, for you to give me the graph of the function, the algebraic function, so f of x equals x squared, f of x equals x, whatever it may be, the domain and range, and a couple other things, okay? You need to know these 8 basic functions off the top of your head so you can do the transformations that we do today, okay? So at the end of the period, I'll give you this and I'll talk a little bit more about it. The exponential and logarithmic graphs that were on your summer packet, we're going to talk about those in chapter 3, so you won't have to worry about those quite yet. All right? Okay. So, transformations of functions. Basically, we can take a function, we can shift it up, down, left, or right. We can reflect it 2 different ways, and then we can also shrink or stretch our function. Okay, you've talked about these in Algebra 2, these that we have listed up here, so you're going to help me. Okay, if we want f of x to shift up, how c units, we're just going to say c, c could be any number. How do we get our function to shift up? What would that look like? Yes.
Plus c on the outside.
Okay, good. We would want to say f of x, and then we would add c, and it would move up, c units. Okay. Anything on the outside of our function is going to affect the y coordinate. So since plus c is on the outside of that function, it's affecting the y coordinate. We're moving up. Okay, so if we want our function to shift down c units, what would we do?
Subtract.
We would subtract c. Okay? Now you don't have to write this entire question in your notes. You can say shift down and f of x minus c. Okay? You don't have to write every single word on my slide if you don't need to. Okay? All right, right and left. Be very careful here. How do we get a function to shift to the right? Very good. We want to subtract c inside of our parentheses. Okay? I know it feels that we should go plus c for right, but it's actually x minus c to go to the right. Okay, if you think about it, if we set this equal to 0, okay, we'll get x is c, and that would be where we're going, okay, to the right, a positive c, and that's why it's like that, okay. Shifting to the left, what would we do?
Add c.
Add c where? So inside. Okay, anything that is inside of our function is going to affect the x coordinate. Okay, so if it's inside the parentheses, it's affecting x. If it's outside, it's affecting y. Okay. Okay, reflections. How do we get a function to, or a graph to reflect about the x-axis? So it's up here, I want it to reflect across the x-axis. Okay, if we put a negative in front of our function, that is going to make our function turn upside down, if you will. Here again, if we're reflecting about the x-axis, okay, if we're going from up here to down here, our y-coordinates are being affected. That negative is on the outside of our function. Okay, how do we get a reflection about the y-axis? Okay, probably something with a negative. Negative's going to go inside at the negative x. So at least these first 5 you dealt with thoroughly in Algebra 2. This reflection about the y-axis you probably talked about, but you might not remember it. You may not remember working with it. Okay? We need to know all of these equally. Now, we also can distort the shape of our graph. Okay, so these are all called rigid transformations because they don't affect what the graph looks like. It just affects where it is. Okay, we're going to talk about 4 non-rigid transformations. These are the ones that are going to stretch or shrink our graph, and they make the graph look a little bit different than the parent graph. So we are going to talk about vertical stretch, vertical shrink, horizontal stretch, and horizontal shrink. Okay. Now, let's just talk about what you remember from last year. Okay. If we wanted to make like a parabola or a absolute value wider, does anybody remember what we did? We had an absolute value, and if you wanted it to be wider versus it being narrower, do you remember what happened?
You put a number greater than 1 in front of the x.
Okay, a number greater than 1 in front of the x, what did that do? Make it skinny or wide?
Wider. Or skinnier. Wait. It is skinnier.
Okay, I always like to think about an absolute value because an absolute value sometimes you can think of the slope on each side, right? Here is absolute value of x, right? Okay. Absolute value to absolute value of x. Would that be skinnier or wider? Skinnier. You can think of slope, right? Up 2 over 1, up 2 over 1 is going to make it skinnier. Okay? So this right here is what we call a vertical stretch. Okay? If we take this absolute value and we make it skinnier, we're stretching those y values up. Okay? So if we put a number in front of our function where that number is bigger than 1, we're going to be stretching all of our y values. Okay. Since the number is on the outside of our functions, it is affecting our y value, okay? To apply this transformation, we're going to multiply our parent function y values by whatever c is. Okay? So whatever our y values are for our parent graph, you're going to multiply them by C. So this graph that I have up here, all of these y values, if I multiply them by 2, and that's where they are in our new graph. Okay. So if we want our graph to shrink vertically, how are we going to rewrite that rule? Okay. If we have a C multiplied to the outside, but now C is less than 1, okay, we're going to have a shrink. So if you want to picture our absolute value that we have drawn over here, it would get wider. Same thing, our y values from our parent graph, we're going to multiply those by C, and those become our new coordinates for our new graph. Do you remember how, I'm going to come back, over here, if something was inside our function, these left and right shifts, these are backwards from sometimes we would like them to be, right? When we think plus, we want to go to the right, all right? Anytime we are inside, things are affected kind of the opposite way, all right? So I want you to keep that in mind when we're talking about our horizontal stretches and shrinks, okay? A horizontal stretch means we're taking the x values and we're stretching them out, all right? Where do you think we're going to multiply that C? On the inside. Our graph is going to be affected horizontally, so with the x values, so we want something inside of our function. So if we want a horizontal stretch, we are going to put a C inside of our function. So for a stretch or shrink, we're going to multiply C on the inside, okay? Here's where you need to be careful, okay? If we are stretching our function vertically, what's happening horizontally?
Small.
Okay, horizontally we're getting smaller. So if we're stretching vertically, then horizontally we are shrinking. Okay, so for a horizontal shrink, C is going to be bigger than 1. Okay, because it does the same thing as like a vertical stretch would. A vertical stretch and a horizontal shrink go hand in hand. Okay, so for a horizontal stretch, C would need to be less than 1. Okay, because if we're stretching horizontally, that means vertically we are shrinking. Okay, now to apply a horizontal stretch or shrink, okay, we are going to multiply all of our x values from our parent function by 1 over C. Okay, remember things get affected kind of backwards when they're inside of our function. Before subtracting meant we went to the right. Okay, so here, instead of multiplying by C for our horizontal stretch and shrinks, we're going to multiply by 1 over C, the reciprocal. Kind of like we're dividing by C. Okay, so I am going to ask you to do a couple things. First of all, I'm going to give you a graph. It may not be a parent graph, just any graph, and I'm going to give you some function notation, and you're going to have to draw me the new graph. Okay, so that's what we're going to work on first, and that's also what our activity is going to look like tomorrow. Okay, function notation is really important, and the more we practice it, the better. Okay, I know some of us are kind of out of the habit of function notation. Okay, second thing is we're going to deal with all of our parent functions with transformations. So I'm going to give you a function. You're going to have to tell me what the parent graph is, what the transformations are, and then be able to graph it. Okay, we can save a lot of time if we can sketch a graph based on the transformations, as opposed to making a little XY table and things in and then graphing it. The whole point of today is so that we can get a graph very quickly and efficiently. Okay, so let's work on this. So this is the graph that we are going to shift. We're going to do this like 6 or 7 times. Okay, this graph right here we're going to apply different transformations to. So this is what we call f of x right here. Okay, that is our f of x. First thing I want to look at is f of x plus 2. Oh. Okay. F of x plus 2. You know what, guys, I'm going to have to calibrate. What does f of x plus 2 mean? What's going to happen to our original graph? Where's it going to go? I have a left 2 and an up 2. Which one is it?
Up 2.
Up 2. It's on the outside of our function, so it's going to affect it vertically. Okay. If it was to the left, where would that plus 2 be? It would be on the inside. Okay. Very good. So we're going to take all of these coordinates and shift them up 2. And there's our new graph. Here we have y equals f of x minus 2. What does this mean we're going to do with our function? We're going to take all of our coordinates and we're going to shift them to the right 2. And there's our new function. Questions? Doing all right? Okay, right now we're just going to work with kind of like one transformation at a time, and then we'll start throwing a couple in there. Okay. Here we go. 2 times f of x. First of all, what kind of stretch or shrink is this? Vertical or horizontal? Vertical. Are we stretching or shrinking? We're stretching. Okay, if you think back to last year, like what would happen if this was an absolute value? Okay, it'd get skinnier, right? Which means all of those y values are stretching. Okay, so to apply this vertical stretch, what do we do? First of all, is it affecting the x or the y coordinate? The y coordinate. So all of our y coordinates, what do we have to do with them? Multiply by 2. So this y value is -1. It becomes -2. The x stays the same. The y becomes -2. Here's the coordinate 0, 0. The y coordinate is 0. The new y coordinate is 0. This coordinate is 3, 1. 1 is our y. It becomes 2. So now it's 3, 2. Here is the coordinate 4, 2. Our y coordinate is 2. It becomes 4. So there's our new graph there. Okay, it's stretched. Seriously. See me hitting it, right? Okay, there we go. Hey, here's one. Negative f of x. What happens to our graph? Reflects over the x-axis. The x-axis is a mirror. So instead of 0, negative 1, this point becomes 0, 1. 0, 0, it's on the axis, so it gets to stay. This point is 3, 1. It becomes 3, negative 1. It's going to cross over on that mirror, and then 4, 2 becomes 4, negative 2. All right. Couple more. Okay. F of x plus 3. What's happening? We're going left 3. See, you guys are getting the hang of this. What do you think? Feeling good about it? Okay. Let's talk about what this one is. Reflect over the y-axis. Okay. So your y-axis is a mirror, and all of those points are going to get reflected over here. Okay. We won't graph that one. We're going to graph one more, and then we'll get into the meat of the lesson, okay? This one, what's happening? First of all, is it a shift, reflection, or stretch or shrink? It's a stretch or shrink. Horizontal or vertical? It's horizontal because it's inside. Is it stretching or shrinking? It's stretching. How do we apply this transformation? Okay, we're going to have to take all of our x values and we're going to have to multiply them by 1 over c. 1 over c would be what? If c is 1/2, what's 1 over c?
2.
It'd be 2. So this coordinate is 0, negative 1. What does it become? It stays there, okay? This coordinate is 1, 0. And so if we multiply the x by 2, it becomes 2, 0. This coordinate is 3, 2. 3, 1. If we multiply the x by 2, we get
6.
And this coordinate is 4, 2. It becomes
8.
Okay, now the most, so this is half of working with the transformations, okay? And this is kind of what your activity tomorrow is going to look like, all right, as far as the function notation is concerned. Now, in your book, you'll have a lot of these problems, okay, as well, where you're going to get a function that looks like this. You're going to have to tell me what the parent function is, describe to me the transformations, graph it, and then write this function up here in terms of f of x, and I'll get to that at the end, okay? So first of all, I want you to look up here. What would our parent function be? Okay, our parent function is x squared, just a nice parabola, right? So our parent function we're going to call f of x equals x squared. Now, you're going to fill out that chart, but let's just remind ourselves what x squared looks like. Okay, there it is. We have a point here at 0, 0. What are these points right here?
1, 1.
1, 1, and negative 1, 1. Those 3 points are the most important to me. I want to see those 3 points on every single graph that you draw. Okay? So, describe the transformation. What is happening here?
Right 1.
Okay? We're shifting right 1 and down 2. So I'm going to take those 3 points from our parent graph, and I'm going to shift them right 1 and down 2. So our vertex is going to go right 1 and down 2. And we have these 3 points right here. Okay. Now we want to write g of x in terms of f of x. Okay, this is the part that people get hung up on. It's not as complicated as it sounds. Okay, so g of x right now is x minus 1 squared minus 2. Since f of x is x squared, we are going to write this as g of x is f of x minus 1, since x minus 1 is inside our function, and then the minus 2 comes afterwards. Okay, this is just basically putting it in general form so we can maybe apply this, like we could change our parent function and apply the same transformation. Okay, this is what your function notation looks like. X minus 1 is inside the square, so it's going to stay inside of our function notation. Minus 2 is after, and so the minus 2 stays outside.
Not the square. You don't keep the square.
Well, f of x is x squared, and so since there's this f of x minus 1, when we go back up here, we know that we would plug x minus 1 into the square. Okay?
Yeah.
Other questions about that? I know it feels kind of awkward. And we'll go through another example. Okay? But when you're working with a parabola, I want these 3 points. Okay? If you're working with an absolute value, I want those 3 points as well. Okay? That way, if there's some sort of stretch or shrink, I'll be able to see that in those 3 points. Okay? All right. One more example. Okay. What is our parent function? Radical x. This is going to be on your 8 basic functions chart. What does radical x look like? Show me with your arm. Like this, right? It starts where? Okay. And it kind of makes this little shooting star pattern is sometimes what I like to call it. Okay. What is the next pointer besides 0, 0? 1, 1. I need to see at least 0, 0 and 1, 1 with your shifts and whatnot. Okay? So let's describe our transformations. What's happening in this graph? A vertical stretch and a shift right 1. Okay? Shifts are applied last. Shifts are the lowest priority. We apply them last. They're the easiest to apply. Okay? Your stretches should be applied first. Stretches or shrinks. Then your reflections, and then you can shift them. Because if you shift before you stretch, then things are going to get all funky. Okay? So, first of all, let's talk about stretching. Very lightly, I'm going to put our parent function on here. Okay? We have a vertical stretch of 2. What does that mean we do as our coordinates? We take the what?
Y.
The y's, and we multiply by 2. So 0, 0 becomes 0, 0, and 1, 1 becomes 1, 2. So what happens is we're kind of doing this, right? We make it stretch a little bit. Okay? Then we have to do what? Then we can shift it right 1. So notice how our shooting star, you know, has a little bit more steepness to it, right? Okay. Last thing, right, in terms of f of x. So our h of x right now is 2 squared of x minus 1. Instead of the square root, I want f of whatever. So there's a 2 multiplied on the outside. It's going to stay on the outside. And then our function is radical x. Since I have x minus 1 inside of the radical, we're going to write this as f of x minus 1. Domain and range is one of the most important topics that we'll talk about throughout the entire year. Let's talk about the domain and range of this function. What is the domain?
All reals.
All reals?
Greater than 0. Greater or equal to 0.
Okay, here's 0. Do we have any function there? No, we begin at x is 1. So that's where our domain needs to begin. So we begin at 1 and it continues to grow, right? Do we include 1? We sure do. Okay. Our range. Where do our values begin? At y equals 0, and they continue to grow. Do we include 0?
Yes.
Yes. I will tell you, you will have to do domain and range on almost every single graph on your test. So if you want to practice in your homework, you're more than welcome to. Okay. So this is what you have for me this evening. Okay. You have problems from 1.6. So these are problems about the stair function, and these two are two piecewise graphs. Okay, so you have 2 graphs right there to do. And then from page 72, that's all your work with transformations. Okay. As promised, I will hand out this 8 basic function chart that you need to have filled out. I will give you until Wednesday to fill it out. Actually, you know what? I'll even, I will give you until Thursday to fill it out. The sooner you fill it out, the better. But I will give you till Thursday. Friday, you're really going to need it because we're going to do an